In for repair today is an optical keyboard with some switches that aren't working. An optical keyboard uses an IR LED to beam light at a phototransistor, and when the key is pressed, it disrupts that path of light, and that lets the keyboard know that a key has been pressed. So we're going to plug this keyboard in, and we're going to see what keys aren't working, and it turns out this entire bottom row of keys are not registering. So this entire row up until the backslash and the question mark is not working. I have a feeling that that is part of a different configuration. So before I start really diving into this, I want to make sure that we have a common supply for the IRs and the phototransistors. So to do that, I'm going to take my multimeter on continuity mode, touch the positive of one IR LED pad. This one is not populated, but it should still be in parallel. So touch that, touch this one. We have continuity, and we should have continuity all the way across, which we do. Now I'm going to do the same thing for the phototransistors. Touch positive of the phototransistor, and go over here, and there's a common there as well. So next we can plug this back in and make sure we have our positive supplies for the phototransistors and the IRs, and continue on from there. So now I'm going to break out the tiny oscilloscope and see if I can measure some signals going from good IRs, good phototransistors, and compare them to the bad row and see if we can isolate anything from there. I'm going to take my oscilloscope ground lead and just kind of press it up against the USB-C housing, which is grounded, and then I'm just going to probe the good rows and reference them against the bad row. So I'm going to probe a good IR positive. We have a nice looking square wave. I'm going to touch the negative as well. Another square wave, positive of the phototransistor. See if I can clean it up. Looks good, and the negative looks about the same. So I'm not going to dig too much into these waveforms just yet. I just want to compare them to the bad row. So now that I have a reference of the good row, I'm going to go to the bad row and probe them. So the positive of the IR looks the same. The negative as well. The negative of the phototransistor looks the same, but the positive of the phototransistor does not look the same. And since they're all in parallel, oh, my computer went to sleep. There we go. And since they're all in parallel, we can expect that across the entire row. Yeah. So now I know what side of the circuit to look at, or what point of the circuit to look at. So we're going to look into the positive side of the phototransistors. They all share a common path, so it should be pretty easy to find. So now I'm going to follow that positive trace for the phototransistor and see if I can find a broken connection. After a few minutes of beeping out traces, I think I found a broken via. So all of the positive phototransistor leads tie into this via right here, or this trace right here, through this via, and it runs over to this via. And on the flip side of the PCB, there's a trace from that via that runs to a microcontroller, or the microcontroller. There's only one, right here, that I scraped away some solder mask on. And as you can see, we don't have any continuity, so that is probably our issue. So I'm going to go ahead and see if I can stab a fine piece of wire through that via and see if I can restore connectivity and fix this keyboard. To fix this, I'm going to scrape away some solder mask covering the via and then stab a wire through the via. This has like some weird coating or insulation in the via which didn't work. That made it a little bit difficult to shove a wire through it, but with some acetone and just constant back and forth prodding, I finally got it to break through. Once it's through, I'm going to go ahead and tin the exposed copper, tin that wire, and fold it over and solder it right on top to repair that broken trace from top to bottom. And with that repaired, this entire row of keys now works. However, during testing, I found that we had another cluster of keys that weren't working. And this was due to another damaged via near the original damaged via, meaning there's probably some localized water damage. So I'm going to go ahead and fix that the same way, just stab a wire through the via that was exposed and solder it on both sides. After I tested the keys to make sure that they were all working, I touched up all the exposed copper with some conformal coating, and now we can go ahead and reassemble this thing and ship it back. And just for fun, here's a final test of the keyboard, proving that every single key works. I threw on a cap set that I had on hand because it was better organized than the original keycap set, which is in a box, and I didn't feel like picking through them right now for this video. The only keys that I wasn't able to prove work are the Windows key, but it does kind of work. Every time I pressed it when it was hooked up to my cell phone, it would launch Bixby, which proves that it works, just not on this tester website thing. The other key that I wasn't able to prove to work was the one that says code. That is a key that I think is specific to the keyboard, and I wasn't able to figure out how to make it work. However, looking at the signals on the oscilloscope, it is working, so I'm confident in that. Thank you so much for watching this video, and thank you to PCBWay for making this repair possible. Speaking of PCBWay, they are the sponsor of my channel, and I cannot thank them enough for their support. They offer a variety of services ranging from standard PCBs, rigid flex PCBs, 3D printing, CNC machining, sheet metal, and vacuum molding, and the list goes on. They even offer PCB assembly, so if you don't want to solder something, you send them a file with a request to build it themselves with a BOM that you supply, and they will solder it for you and deliver you an awesome quality PCB. Same goes for 3D printing. If you find something online that you want 3D printed, send them the file and they will send you a 3D printed object. Thank you so much to PCBWay for sponsoring my channel. Let's get back to the video.